Hello everyone, this is Baswant Organti. I am planning to do a series of video lectures on chemical bonding. So in the present lecture, I will discuss what is a chemical bond and what are different theories of chemical bonding proposed over the years. So let us start. So what is a chemical bond? Are chemical bonds real? Can we see chemical bonds? These are the questions that have intrigued chemists from so many years. For example, so this is a quote from Charles Colson. So he was describing a nightmare he got in a conference. He said, these concepts make chemical bonds seem so real, so lifelike that I can almost see it. Then I wake up with a shock to the realization that a chemical bond does not exist. It is a figment of imagination that we have invented. So he says when he wakes up, he sees that there is no chemical bond, it's just a kind of imagination. When I was in my high school, I used to think whether we can see chemical bonds or not. In our school or intermediate college textbooks, when we say a chemical bond, it's defined as a force of attraction that holds atoms together in a molecule. But I was wondering whether we can see the chemical bonds in real. So this quote is taken from 1980s, but nowadays we can really see a chemical bond using atomic force microscopic images. So these are images taken from two research articles, one from 2009 and the other from 2013. So here you see that atomic force microscopy images of 8-hydroxyquinoline. So using atomic force microscopy, we can really see the electron density, which is nothing but the chemical bond, the electron densities, we can really see. And on the right hand side, you see the pentacene electronic density, which is the chemical bonding in pentacene. So yes, today we can really see chemical bonds. But how do we understand chemical bonds? So what is the nature of a chemical bond? So over the years, many theories were proposed by different scientists to understand chemical bonding. One of the first persons to propose a comprehensive theory on the nature of chemical bond is Lewis. Lewis proposed a chemical theory called electronic theory of valence in 1916. So after that, one very popular theory is valence shell electron pair repulsion theory, which was proposed in 1940s. However, these two theories did not consider development in quantum mechanics. They are just classical theories that treat electron like particles. They don't treat the wave nature of the electron. For example, during the development of quantum mechanics in 1920s, people realized that electrons have dual nature, both particle nature as well as wave nature. Later on, other theories were developed like valence bond theory and hybridization, as well as molecular orbital theory, which considered the wave nature of the electron and took orbital concept, the wave function of the electron called orbital, as a core concept in describing chemical bonding. So first I'll give you a brief overview of Lewis theory in this lecture, and in the subsequent lectures I'll talk about Westport theory and valence bond theory as well as molecular orbital theory. So let's start with the Lewis theory. So according to Lewis, what is a chemical bond? So he proposed that a chemical bond is an electron pair pair of electrons constitute a chemical bond. So further, he explained that some species are extremely stable. So these stable species have 8 electrons in their valency shell. So the total electrons are divided into 2 parts. Electrons which are present in inner shells and electrons which are present in outer shells. Electrons present in inner shells are called core electrons. Electrons present in outermost shells, they are called valence electrons. Core electrons do not usually participate in a chemical reaction. It's the valence electrons that do participate. Lewis proposed that so species which are having octet configuration, that means which are have 8 electrons in their valency shell, like neon, argon, krypton, which are called noble gases. These are very stable. They don't react. They are not very reactive. Of course, they sometimes react, but they are not very reactive. And also helium, which has a doublet configuration, 2 electrons in the outermost shell, which is also inert or not very reactive. So then he said that all other species tries to attain this stable configuration, either 2 electrons in the outermost shell like helium, or octet configuration like 8 electrons in the outermost shell by reacting with other atoms, either by sharing of the electrons, which he termed as covalent bonding, or either by transfer of electrons, which is called ionic bonding. As a matter of fact, Lewis said that no bond is perfectly covalent, no bond is perfectly ionic. These are 2 extremes, covalent and ionic bonding. Each bond has some covalent nature and some ionic nature. This is a very important point, usually not mentioned in the textbooks. But if you see the original research paper of Lewis, you find that he says that there is a continuum from a covalent bonding to ionic bonding, and only few bonds form in the extremes, and there are many bonds that are in between, which have some covalent nature and some ionic nature. So these pictures that you see, these are very popular in high school and intermediate textbooks. These are electron dot pictures, which are very convenient to represent a bond. A bond is a pair of electrons, 2 electrons constitute a bond. So here, for example, you see that there are 2 fluorine atoms. Fluorine has 7 electrons in the valency shell. So it needs 1 more electron to get 8. So it approaches 1 more fluorine atom, which also requires 1 electron. So the 2 fluorine atoms, they contribute 1 each, and the pair of electrons are shared by both the atoms, such that each fluorine atom feels that it has achieved an octet configuration. So this is a covalent bond in between 2 fluorine atoms in a chlorine molecule. Similarly, we can see some other example. The main focus of Lewis theory is a bond is an electron pair, and species tries to attain octet configuration by sharing electrons or by transfer of electrons. Now let us take the example of sodium chloride, NaCl. So sodium, it has 1 electron in its valency shell. Chlorine, it has 7 electrons in its valency shell. Chlorine requires 1 more electron to achieve octet configuration. Sodium, if it loses 1 electron, it gets the octet configuration of neon, because atomic number of sodium is 11, atomic number of neon is 10. So neon has octet configuration. In addition to the octet configuration of neon, sodium has 1 more electron. So if it loses this electron, it will achieve the octet configuration. So sodium loses the electron and achieves octet configuration. And a plus, it loses electron, loses negative charge, so it becomes positive. Chlorine, it takes away this electron, it gained electron, it gains electron, so it has negative charge, Na plus and Cl minus. So these two are oppositely charged species, so they attract each other. So this electrostatic force of attraction is termed ionic bond. So in this way, Lewis explained covalent bonding, ionic bonding, and how we can use octet rule to understand how elements react with each other. So this is a wonderful theory proposed by Lewis in 1916. However, there are some limitations. Maybe we can't say failures, but there are some limitations. Lewis theory could not explain what is the structure of a molecule. If given a molecule, how this molecule will look like. It could not explain the structure of the molecule. And there are many molecules that do not obey octet rule. For example, if I take PCl5, so phosphorus forms 5 bonds with chlorine. So what is a bond? Pair of electrons. So 5 bonds is 5 into 2, 10 electrons. So there are 10 electrons in PCl5. There is no octet configuration around it, but still it's stable. Same is the case with BF2. It does not obey the octet rule. It has 2 pairs of electrons and no lone pairs. So there are total 4 electrons surrounding it, but it's still stable. And as already pointed out, it does not take into account the wave nature of electron, the quantum mechanical properties of electron, like the wave nature of the electron. As we have seen in the last image, we are representing the electrons as dot. Like it's like a particle we are representing, but we are not taking its wave nature, its wave function into consideration. So these are the limitations of Lewis theory. In my next video, I'll talk about Vesper theory, valency shell electron pair repulsion theory. Till then, thank you. See you in the next lecture.